Good day, students. Today we are going to continue with the law of conservation of linear momentum. Law of conservation of linear momentum. Recall that the law of conservation of linear momentum states that the total momentum before collision is equal to the total momentum after collision. That is, m1u1 plus m2u2 is equals to m1v1 plus m2v2. So, this is the law of conservation of linear momentum presented in mathematical form, where u1 and u2 are the initial velocities of the two colliding bodies, whose masses are m1 and m2. v1, v2 are the final velocities. v1, v2 are the final velocities of the two bodies. Example 1. Particle A of mass 2 kg is moving with speed 3 meters per second on a smooth horizontal surface. Particle B of mass 3 kg is at rest on the surface. A collides with B. After impact, A continues to move in the same direction but with a speed of 1 meter per second. Find the speed of B. Find the speed of B. That is the question. That is the question. So, solution. Solution. Given data. Given data. Mass m1, mass m1, mass m1 is equals to, or let me put it this way, mass of particle A. Mass of particle A is equals to m1, which is equals to 2 kg. Mass of particle B is equals to m2, which is equals to 3 kg. Initial velocity. Initial velocity of particle A. Initial velocity of particle A is equals to u1, which is 3 meters per second. Initial velocity of particle B is equals to u2, which is equals to 0. Which is equals to 0, because it is 0 because it's at rest. We're told that particle B is at rest. Now, so total momentum. Therefore, total momentum before collision. Total momentum before collision is equals to m1 u1 plus m2 u2. That is equals to, we said m1 is 2 times u1. u1 is U1 is 3. Then plus M2. M2 is 3 kg times U2, which is 0. So, the total momentum before collision is 6 plus 0, which is 6 Newton seconds. Yes, I think, yes, the SI unit of momentum is Newton seconds. That is the total initial momentum before collision. Total initial momentum before collision. Now, final moment, the final velocity. Final velocity. Velocity of particle A. Final velocity of particle A is 1. Final velocity, that is V1. Yes, V1, which is 1 meter per second. Final velocity of particle B.
1.
1 also. Yes. So, after impact, A continues to move in the same direction, but with a speed of B. No, we don't know the final velocity. It's what we're looking for. Final velocity of B.
Okay.
Is what we're looking for.
Okay.
Final velocity of particle B is equals to V2, which is what? Question mark.
Question mark.
Which is question mark. Now, total initial momentum after impact, after collision, is equals to M1 V1 plus M2 V2. And that will be equals to, what is M1? M1 is 2. 2 times V1, which is 1, plus M2, which is 3. M2 is 3, yes? No, yes, it's 3.
Yes, 3.
M2 is 3 times
V2.
V2. So what do we have? This will be 3V2 plus 2. Is it not?
Yes.
So, now, going by the law of conservation of linear momentum, I can clear this side now. So, according to the law of conservation of linear momentum, we are saying that the total momentum before impact is equal to total momentum after impact. So, it means 3V2 plus 2 is equals to 6. Is equals to 6. So, 3V2 is equals to 6 minus 2. Which is 4. Therefore, V2 is equals to 4 over 3. 4 over 3, which is the same thing as 1/3 meter per second. That is our answer. That is the answer.